Okay, so in this problem, it's mentioned that we're looking for pairs of AB positive integers such that A is less than equal to B and this condition is fulfilled. There are people who actually mug up these kind of questions. It's not suggestible because in CAT, most of the time you will be given something additionally, or it will mention even numbers and stuff like that, and then you will mess up. So don't try to mug it up. Understand wherever the idea is generating from. They are not tough ideas. If they are, they will not be tested in CAT. So it's a very simple idea. Whenever you have a question like this, just take an LCM and cross multiply. So once you do that, you'll find something like this. Just evaluate on this. I hope I don't have to show the steps. Just take the LCM and cross multiply. You'll find this. So once you do this, now just get everything on the same side. So the next step is very vital after this. So once you do this, now whenever you have something of this form, this can be actually factorized. But once you factorize this, this will not remain zero. This will change in value. Let me show that to you. So first, let us take a common. So we have a b minus 9. Now here, what I can do is I can take a 9 minus 9 separately, and I can force a b minus 9 here. Now once I force a b minus 9, what we have essentially done is we have added this minus 9 into minus 9. So that is 81 on the left hand side. Now, if we have added this 81 on the left hand side, in order to balance this equation, we also need to add an 81 on the right hand side. So once you evaluate this, now the factorized form should be simply in front of you, right? So this is the one we are working with. Now let us look at this problem here. So this is what the question transposes to. So we have a minus 9 and b minus 9. Let me write this properly, just 1 minute, 1 second rather. A minus 9 into b minus 9 equal to 81. Now, what are the constraints that are given to us? So a, b are positive integers, first of all. Now, if a and b are positive integers, it's not mandatory that a minus 9 and b minus 9 has to be positive, right? I mean, if a is positive, a minus 9 could be negative. So let us consider two cases here. One case, both are positive because the product is positive, one cannot be negative and another cannot be positive, right? They have to be of the same sign. Either they are both positive or both are negative. So let us work on this case because the first case is easy to handle. I mean, this will always work out. What I mean is, if a minus 9 is positive, then a is definitely positive, right? So I don't have to worry about that. The only thing I'm concerned about is this negative thing. Can it be allowed or not? So let us work on that. So suppose both are negative. So what does that imply? Now, if a minus 9 is negative, what I get is, sorry, so this is 0. A is less than 9. Now, since A has to be positive, so don't forget that A has to be a positive integer, right? So implies this 1 by A will be greater than 1 by 9, right? Because A is less than 9. So 1 by A should be greater than 1 by 9. You can just take a random example. 5 is less than 9. 1 by 5 is greater than 1 by 9, right? Don't take this example until and unless you're sure that it's a positive integer. The significance of that is if it's not mentioned that A is a positive integer, minus 5 is less than 9, minus 1 by 5 is still less than minus 1 plus 1 by 9. So don't do it until unless you're aware of positive integers. So anyhow, but positive numbers rather, not integers necessarily, but you know that positive numbers. So coming back to the problem, so this case is not only saying that a minus 9 is negative, but it also says b minus 9 is negative, right? But if b minus 9 is negative, with the same approach, we will also land at something like this, right? 1 by b is greater than 1 by 9. Now, understand this. This was a transposed problem, right? I mean, this was not the original problem. The original problem was this. Now, check this out. So, if 1 by a is greater than 1 by 9 and 1 by b is greater than 1 by 9, how do we have something that is, I mean, two numbers which are greater than 1 by 9 and then add them up to get 1 by 9? That is not even possible, right? So that is how you can rule out this case. So essentially we end up with both being positive. Now it is very simple problem because what are we looking for? There are two things that we have to understand here. One is that both of them are factors of 81, isn't it? So they are factors of 81. So we are essentially working with factors. For each of the factors that we plug in for a minus 9 and b minus 9, we'll automatically get a solution for a and b, corresponding solution for a and b. And the other thing that we are plugging in is this a less than equal to b. But since there is a symmetry here as well, both are subtracted by 9, reduced by 9 rather. What I meant to say is, if a is less than equal to b, then a minus 9 should also be less than equal to b minus 9, right? This should automatically be understood. So once you understand this, all you have to do is put the lower factor here and the higher factor here. If both are equal, that is allowed because a could be less than, equal to b as well. So a minus 9 could be equal to b minus 9. But essentially, what I'm looking for is a minus 9 never be greater than b minus 9. So let us simply write the factors here. 81 is a very simple number. It's 3 to the power 4 after all, right? So let us simply write the factors. So one thing we can do is we can put in 1 here and we can put the 3 to the power 4 here. This is possible. 1 is less than 3 to the power 4. We can put a 3 here and we can put a 3 cube here. The product is still 3 to the power 4 and 3 is still less than 3 cube, right? And finally, what we can do is we can plug in 3 square and 3 square on both the sides, right? In that case, the product is still 3 to the power 4 and it is equal. So that is not violating the constraint. So essentially, if you look into this solutions that we have a total of 3 solutions, right? And that is what we are looking for, the number of solutions of AB. And what I initially mentioned, so if A minus 9 is 1 and B minus 9 is whatever, essentially for each of the solutions of A minus 9 and B minus 9, you will have a solution of A comma B, right? So for example, in this case, you will have A equal to 10, and in this case, you will have B equal to 90. So you don't have to worry about it. It will automatically evaluate. So essentially, we have 3 solutions for A comma B as well. So that is the answer for this problem. So do it in simple manner. Don't try to by heart and for these kind of simple things. You don't have to. I mean, keep your mind as free as possible with less things to remember. That will encourage you, or after all, that will যে পার্টটা বলছিলাম না সেখান থেকে আরেকবার বলছি, কি একটা বলে ফেললাম জানি না। তো ওই জায়গাটা থেকে জাস্ট ক্রপ করে দিও আরেকবার, দ্যাট উইল পার্টটা জাস্ট কেটে এইখানটাতে এইটা ঢুকিয়ে দিবি, ঠিক আছে? দ্যাট উইল এনেবল ইউ টু অলওয়েজ think properly in the exam with less things to remember. So don't mess up stuff, and don't remember too many unnecessary things. So that's it for this problem. If you understand these ideas, it will take some time to get this. But once you know how to handle these things, this idea that I mentioned, this factorizing idea, is not only essential in this particular problem. It is very, very handy. It comes in handy in a lot of different problems. Even in our classes, we have explained some LCM HCF problems where we can use the similar kind of factorization ideas. A lot of other scope of study where we can utilize this idea. So knowing this kind of things are more useful rather than just mugging up formulas and theorems. So I hope this is understood to all of you. Ideal time, as I was saying, should be around 2 minutes to solve this problem. And 2 minutes is a good time to actually solve this problem, because you won't have too many problems of this type in CAT. You can finish all the questions even if you invest 2 minutes of time in this particular problem. And even if it takes a little bit more, 2.5 to 3 minutes for a problem like this in second round or something, it's still fine. So that's it for this question. I hope that was understood. Thank you.